Hello and welcome back to California Geology. I'm Dr. Robert Lopez, and today I want to finish off the Basin and Range, and I want to talk about the ancient rocks of California. And just like the title of this chapter, Young Faults Exposing Old Rocks. So we talked about the turtlebacks being about 1.7 billion years old. And this is kind of common for the western United States. There are some rocks in Arizona in the Grand Canyon that are also 1.7 billion years old. Those are called the Vishnu Schist. And both the turtlebacks in Death Valley and the Vishnu Schist are metamorphic. So there must be either continental collisions. You're forming larger continents during this time. And there's a whole intricate history for continental formation in the Precambrian. And this is one of the episodes. And also these older metamorphic rocks are intruded by 1.4 billion year old granitic pegmatites. They're exposed in the Black Mountains and also the Panamint Range. In the Death Valley, they're quite abundant. It's called the Zoroaster Granite there. And again, the granites indicate maybe an episode of mountain building. So certainly there's some mountain ranges. There's episodes of continental formation going on in the Precambrian time. Now, remember I talked about the Kansas model early on, and the Kansas model refers to California was in the middle of some supercontinent, right? And that supercontinent geologists call Rodinia. And you'll read in chapter 18, I'll assign a couple of pages out of chapter 18, it's a Russian word for mother homeland. So California was in the middle of this continent. So recall this diagram I showed you earlier, where in this Kansas model, California is in the middle of this continent. So at some point, this continent has to break up, because obviously California has faced an ocean for a long time. But under this scenario, it was in the middle of a continent. So that's the first thing that's going to happen. We're going to start rifting this continent, rifting Rodinia. And the key evidence for that, I ask in the study guide, what rocks tell us that Rodinia rifted? And that's called the Pahrump group. And your book says the Pahrump group's anywhere from 1.2 billion years old to about 700 million years old. And so these are the rocks that are evidence for rifting of Rodinia. And so here I'm kind of showing a model where Laurentia is what geologists call ancient North America. And so here we're rifting, we're causing these normal faults, as blocks are dropping down, and we're filling this basin up with sediment. And there are three important formations. There's this older Crystal Springs Formation, the Beck Springs Formation on top of that, which is a limestone, and then kind of a conglomeratic, maybe even a glacial type deposit of tills is the Kingston Peak Formation, right? So these are the three formations of that Pahrump group. But more importantly, this Crystal Spring Formation has these basaltic or diabase intrusions, these intrusions that intrude up, which indicate that the continent's rifting, the asthenosphere is coming up, we're seeing decompression melting, and we're seeing intrusion. In fact, eventually these mafic lavas will make an oceanic crust. We're going to make an ocean basin here. And then based on the rocks we find in Antarctica, Australia, New Zealand, that may be the other side of Rodinia that rifted. So now that's, of course, on the other side of the Pacific Ocean. Now, then this leads to the Atlantic type model. So in order to have a passive margin like the East Coast of North America, you have to have a continent to rift. So for the Atlantic Ocean today, Pangaea rifted in the Triassic period. So Pangaea rifts and we make an ocean, in this case, the Atlantic Ocean. So a similar thing happened about 700 million years ago in the Pacific, and made the Pacific Ocean. We rifted Rodinia. So we make this trailing continental margin, a passive margin. No volcanoes, no active faults, mountains are far away. So we end up having a very quiet, stable platform, sort of like the Great Barrier Reef of Australia, where there's lots of carbonate reefs, there's deposits, lagoons, clean quartz sandstones that are very mature. All the mafic minerals have been oxidized. The feldspars are all hydrolyzed to clay minerals. So we're seeing this carbonate platform forming here. And there's some important information that I want you to know that give us a clue to this Atlantic type margin. And those formations in order are the Noonday Dolomite, which is really a type of limestone, the Johnny Quartzite, Johnny Quartz sandstones, and the Sterling Quartzite. There's also another formation called the Ibex Formation, which is kind of part of the Sterling. But the Noonday, the Johnny, the Sterling, all these are interbedded limestone and quartz sandstones, which are very characteristic of passive margins. The only place we see these types of rocks forming are at trailing continental passive margins. And so if we kind of look at a stratigraphy here, we got that Precambrian basement, you know, the 1.7 billion year old rocks with a 1.4 billion year old granitic intrusions. Then we have a great unconformity here with the Pahrump group sitting on top, which is that basin fill, as we're rifting Pangea. Then these rocks indicate that passive margin, the Noonday Dolomite, Johnny Quartzite, Sterling Quartzite. There's a Wood Canyon formation. Another thing I want to point out here is right around somewhere in the boundary within the Sterling Quartzite, we have the Precambrian to Cambrian transition. So remember, the Cambrian organisms basically develop shells, and we see lots of fossils. And some of the oldest fossils on Earth with shells are this Waiachia, and then we see Trilobites. So we can find these fossils in the Panamint ranges and in regions in the Mojave Desert. Now let's look at the PowerPoint here. So we got the crystalline basement here. And then this is the reconstruction of Rodinia, where we have North America here. So Death Valley, California would be in this region here. And then we would see that Australia, Antarctica, maybe parts of New Zealand were out over here. And then we're going to rift. We're going to break this up and deposit that Pahrump group in here. And so here's kind of the sketch. We're rifting Rodinia, and eventually we're making this passive continental Atlantic type margin going on over here. Now, this is a part in Death Valley, that region where we see those mafic diabase sills. So these are intrusions, those basaltic intrusions that indicate the rifting. This is the Crystal Springs Formation back in here. And then here's another model showing how the rifting of Rodinia is occurring, where Australia and Antarctica are rifting away, and we're depositing the Pahrump group in this incipient basin. In fact, this is the beginning of the Pacific Ocean here. And then we see as Australia, Antarctica is moving farther away, we start developing a wider carbonate platform, very stable margin here around 650 million years ago. Now we're getting this passive margin. Now here's some of those fossils, Waiachia, oldest fossil shells in California. These kind of hollow tubes of shells. They're right around 540, maybe 545 million years old. They're right around the Cambrian, Precambrian boundary. And then this is the Avimpah Mountains, which are near the Nevada border. We have all the strata here, all that sedimentary rock of either Paleozoic sediments, again, all in a passive margin. And then this is a nice picture of the Panamint Range. And here we got rocks that are part of the Pahrump group and part of the Noonday Dolomite down here, Johnny Quartzite in here, and Wood Canyon Formation. It's all in here. The whole Paleozoic and late Proterozoic section exposed in here. And they're all capped by kind of young basalt flows up in here. And then I actually took a trip out here with my family to the Marble Mountains. The Marble Mountains are out east of Barstow, and there's this shale here called the Latham Shale, which has fossils of trilobites. And so here are these trilobite fossils. In fact, let's look at some of these trilobite fossils from the Latham Shale. So we'll kind of zoom in on one right here. That's one there, at least part of one. And then we have another one, if you can see that guy in there. Right, so these little fossils from the from the Cambrian. These are about 540 million years old, right? So here's some Cambrian Trilobite fossils, again, from a time in California's history where we were a passive trailing continental margin. So let's stop here and we'll finish up the basin and ring.